Okay, so this graph is kind of interesting. There's an ice sculpture, which is just a sculpture made out of ice. And as the time increases, the height decreases, right? It's inverse correlation, right? So, which makes sense, right? It's going to melt, right? So the height will decrease. So A says calculate line of best fit. So your answer is going to vary, but I would probably say like a line would look like this, right? Or something, sorry, like that, right? Okay. So I would say that the y-intercept, this is A, the y-intercept is 10. And I would even say that the x-intercept is pretty close to 4. I don't know. It's hard to see on my graph because it's so small. Maybe the x-intercept is 4. So if we write that in slope-intercept form, y equals mx plus b, right? The y-intercept is 10, right? And the x and y, the x-intercept is when y is 0. So there's a 0.40, right? We could substitute that in, x, y, right? So y is 0, m is unknown, and x is 4, right? So we get 0 equals 4m plus 10. Negative 10 equals 4m. Negative 10 fourths equals m. So m equals negative 5 halves. So I would say a line of best fit could be y equals negative 5 halves x. What was the y-intercept? 10, right? Plus 10. I don't know. Again, yours will vary because your line is going to be drawn slightly different, but I would say it'd be something close to that. For B, it says, based on your equation, how tall was the ice sculpture 1 hour before Nicholas started measuring? So 1 hour before, right? So that's at time, -1, right? So I substitute a -1 in for x. So y equals negative 5 halves times -1 plus 10. So y equals 5 halves plus 10, which is 20 halves. So y equals 25 halves. Where can I write that? I'll come up to here, right? This is B, right? So y equals 25 halves, or y, the height would be, 12 and a half inches.